All right, Saintsman. Now we have lesson 11.5, the volumes of prisms and cylinders. So, this just has one formula for the entire lesson. So this should be straightforward. We have that, and then we have with us 4 examples. Okay. So volume is equal to capital B times H. It's not going to be this whole thing of length of width and height or blah 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 blah. It's going to all be contingent upon what this base is, and this capital B is the area of the base. So this can change depending on what type of prism or cylinder that we have, okay? Let's first start with the following. I'm going to just teach you guys how to draw a little bit, okay? I know. Directed draw from Mr. Granados. Who would have thought? So I'm going to take a triangle, which I can draw perfectly. All right. Then I'm going to copy it. And then I'm going to draw it, and I'm going to offset it on top of this other triangle, okay? So you guys can do that without having to just draw the 2 triangles on top of each other with one offset. And all we do then from there is connect the vertices. If we do that, now we have this 3-dimensional figure. It's pretty cool. I'm going to make this guy a right triangle. In fact, make that little right angle smaller just so we can see what's going on here. All right. This length is 8. This length is 3. I'm sorry, this length is 5. And this length is 3. And again, this is what's called a triangular prism. Now, it's a prism because we define the prism by the base. Okay? So, the area is equal to 1/2 capital BH for that prism, right? So that's what not the A is, that's what capital B is. I'm gonna, right? So it's the area of that base because of the area of the triangle. So it's 1/2 of the base, which is 5, times the height of it, which is 8, which is the same. You could say one's the height and the other one's the base because it's a right triangle, which is going to be 8 times 5. So it's 8 times 5 is 40, divided by 2 is 20, okay? And then we're going to say the volume is equal to 20, the area of that base. And then here's the lateral height, okay? That is the length between the bases. Remember, and I think that's critical because I want you to think about the following. I'm 6 feet tall standing up. Now, if I lay down, am I still 6 feet tall? Yes, that hasn't changed, right? Because we measure height from the top of my head from the bottom of my feet. So it doesn't matter. You can't say like, oh yeah, the triangle's on its side. It doesn't matter. It's still that, you could put that cheese wedge where it's the length, right, between those fat bases. So this height here has to be 3. So then we take 20 times 3, and this is going to be 60 units. And then when you measure volume, they're going to be cubic units. Okay. Next, let's do a trapezoid. This one's going to be fun. All right. So we draw a trapezoid. Or mine is. Well, I want to draw a right trapezoid though. Okay, I'm going to clean this thing up. Let's try it again. See if the software doesn't fail me this time. There we go. That's a nice one. I'm going to draw the same exact one. So I'm going to take my trapezoid. Oops. I'm going to copy it. I'm going to connect these vertices, connect these vertices, connect these vertices, connect these vertices. Okay? These are right angles. Okay? I'm going to give you all the dimensions of this thing. This length right here is 4.4. This length here is 5.6. This height right here is 2.5. And this length between the bases, which is really the height of the entire figure, is 4.2. we're going to find the volume. I don't need to capitalize volume. Let's have some decent grammar here as a math teacher. We get stereotyped that we're not as good at grammar as the rest. Okay. What's going on here? Okay. V is equal to capital BH. Now, it's the area of the base, right, is the following. Remember, B, it's the area of a trapezoid. So we have to figure out, remember, it's going to be 1/2, and we take the average of the parallel sides, which are going to be 4.4 and 5.6, okay? And then we're going to multiply that times that height, which is 2.5, right? We don't care about this guy just yet. It's the height of the trapezoid itself, okay? So that's the area of the trapezoid, which is going to be 1/2 of 10 times 2.5, okay? Which is going to be 1/2 of 25. Half of 25 is 12.5, okay? So then we're going to take this number and plug it into the area of the base. So volume is going to be 12.5 times this height, okay, which is the length between the bases, 4.2, 12.5. Again, this is a trapezoidal prism. Defined by the prism defined by the bases. And what was that number again? Remind me, 12.5 times 4.2. Your calculator, help us out. It is 52.5. All right. And that is units cubed. Uh-oh. All right. Two more of these things. Let's actually do some cylinders now. Now, cylinder, it's a prism just with a circle, okay, as a base. So, here's already draw a cylinder. This is actually kind of a fun little direct to draw for you guys. Again, I'm going to get my auto shapes on. And I'm going to draw an ellipse. I'm going to copy it. I'm going to put them side by side. And then I'm going to draw from like this top of this ellipse, right? From these points and connect these guys. And that makes my cylinder, okay? And then here is my little radius that I'd have. Let's take the auto shape off so I don't start having it correct my handwriting. It's embarrassing. My handwriting is so brutal that it corrects it. Okay. So this is a circle. Okay. This length right here is going to be 5 meters. This length between the two bases, and I keep drawing all these on their quote unquote side, but there's no such thing as that side, right? That's going to be 9.1. Okay, that's just that edge. Because we have to get our terminology down, and that's just the length between the bases. So the volume is equal to capital B times H. Now we know how to find the area of a circle, since the area is since the base is a circle, there's going to be pi times the radius. In this case is 5 squared, okay? And then times that entire lateral height, which is going to be 9.1, the distance between the bases. So we have 25 pi times 9.1. And we have to put that in our calculator, of course. And that's 227.5. Okay? And of course, that's going to be meters cubed. Oh, 227 pi. 227.5 pi meters cubed. Okay? That pi didn't just disappear. Now remember, the area, my circle, pi r squared. Pi's r squared. Cool, right? Little formula we use right in there. Last but not least, we're not going to get into it. This is what's called Cavaliere's principle. I know this is one of my trust me bro moments that I've told you not to get trapped into. I'm happy to discuss it with you in class. It has to do with when we get an oblique. And we use the same exact formula, okay? And an oblique cylinder works like this. It looks like a slinky that's been tipped to its side. You guys know slinkies? It's this. Take my ellipse here, okay? And it's going to be a little bit offset. So I'm going to take this edge to this edge, connect to this edge to this edge, and connect, okay? But here's the kind of the issue is that from the center to here to get my radius, and I have this length of 7 feet. Let's get the photo shapes off. If I take this right here, it's this height, right? That is going to be like an altitude. That's the height that I'm going to use in my formula, okay? So the volume is going to be equal to the capital B times H. Now, again, it's pi r squared, pi because it's a cylinder. So pi times 7 squared, and then times the height, which is not this length, that's the slant height, right? This guy right here is what's called L, which is the slant height. We actually don't want that. We want to utilize this altitude height, which is 22. So simple enough for us. So that's just knowing which thing to utilize. So we're going to have 49 pi times 22, and according to my calculator, it's 1078. Right, 1078. Okay. So 1078 pi feet cubed. All right, Statesman. And that is the lesson. Good luck.